Delta H naught 1 is the standard enthalpy of formation of methane. Delta H naught 2 is the standard enthalpy of combustion of carbon. Delta H naught 3 is the standard enthalpy of combustion of hydrogen. And we are given the combustion reaction for methane gas, in which it reacts with oxygen gas, giving us carbon dioxide and water, and the balanced equation is given. Now there is given delta H naught C, which expression is equivalent to delta H naught C. First of all, this is a reaction. Enthalpy of a reaction, this delta H naught C, can be calculated as that delta H naught of the combustion reaction for methane is equal to summation of enthalpy of formation of the products. This is products enthalpy. Let me write delta H for products minus summation of enthalpies of formation of reactants. This equation will give us our answer. Now, here the products are carbon dioxide, and they say that delta H naught 2 enthalpy combustion of carbon. When carbon solid is burnt in oxygen gas, producing carbon dioxide gas, the heat or the enthalpy is represented by delta H naught 2. So this is the enthalpy of formation of carbon dioxide which is present in the products. The next species present in the product is water. And we are given a clue enthalpy of standard enthalpy of combustion of hydrogen, that is H naught 3. When hydrogen is reacted with oxygen producing water in liquid form. Oxygen is gas, hydrogen is gas, and we will need half oxygen. Here, the enthalpy of this reaction delta H naught is given as delta H naught 3 according to the question there. So these two were the enthalpies for the products. Now coming towards the reactants. Methane, standard enthalpy of formation of methane, that is delta H naught 1. Methane is formed by burning solid carbon with hydrogen gas, giving us methane gas. So we will put 2 here to balance the equation. Remember, 1 mole of the compound will be formed. So to get 1 mole of the compound, carbon is 1 mole from the start, and hydrogen should be balanced as 2. This enthalpy of formation for methane is 1. The next species in the reactant is oxygen. And remember, all elements, when they are in their standard states, so oxygen gas is in its standard state, they have the enthalpy of formation 0. So now we have all these values here. We'll put these values in this equation, and then we will match it to the choices. So coming towards this equation, delta H naught C, I'm writing here, delta H naught C is equal to summation of enthalpies of product. The product is carbon dioxide and it has enthalpy delta H naught 2, This is delta H naught 2 plus the enthalpy of water, and water has the enthalpy delta H naught 3. But remember, there is 2 molecules of water or 2 moles of water. So we will place 2 here and delta H naught 3. This will gives the summation of enthalpy of products minus summation of enthalpy of reactants. In the reactants, we have methane, and methane's enthalpy is given as delta H naught 1. So we will get delta H naught 1 plus enthalpy of the oxygen, that is 0. So that is 0. Now, the final equation, if you want to choose, that is delta H naught 2 plus 2 delta H naught 3 minus delta H naught 1. So now it is matching to choice D, delta H naught 2, delta H naught 2, 2 delta H naught 3, 2 delta H naught 3 minus delta H naught 1. So correct choice is choice C.